who are, got it. So I'm excited to be a part of this group of researchers funded through the SURA Foundation. And I know that we're all passionate about our work and looking forward to serving our veterans and improving their lives with our research. So I am an early career investigator. I have 2 VA funded grants currently that focus on Parkinson's disease. And so with this presentation here, I'm going to be talking about the Parkinson's disease related study that's a team of interdisciplinary clinicians and researchers have come together to bring forth. So, okay. So Parkinson's disease, really brief background. I think most of us know Parkinson's disease as a movement disorder. And at the bottom left hand of this slide here, there's the typical, when we think about Parkinson's disease, we think about older people who maybe have a shuffle of gait, a hand tremor, lack of balance. But as we see in this larger picture here, that's just the tip of the iceberg. So there are many non-motor problems associated with Parkinson's disease. And so these are the things that people don't see. And you can see along this list why it's so critical really to have an interdisciplinary group of researchers. And interestingly on this list, vision is not listed. So vision is actually the focus of this grant. And Dr. Bruce Gaines is our ophthalmologist who has an eye clinic here at Hines, and Dr. Kalia Coletta, who is a neurologist here at Hines, introduced me to Dr. Gaines, and this was the summer before COVID, or the summer of COVID, the first summer, and together we started talking about the eye, about vision, about Parkinson's disease. And together we started forming this great interdisciplinary team and started coming up with some questions that we were all excited about. So Dr. Gaines is able to measure the function of retinal ganglia cells that are called intrinsic photosensitive retinal ganglia cells. They're in the retina, and he can easily study these in his eye clinic. So he was interested in these as a biomarker, and the more I started to learn about them, I became interested in the cognitive aspect of these retinal cells. And the idea that the eye is a window into the brain just makes sense when you think of the relationship that Dr. Gaines and I have been building, the eye doctor and the brain researcher. So lots of exciting ideas have been coming from these IPRGCs. So IPRGCs are, they're photosensitive. And many of us may know about the rods and the cones that are in the eye. Well, the IPRGCs are a relatively recently new retinal ganglia cell that work along with the rods and the cones. And importantly, IPRGCs are activated by lights, and more specifically by blue lights. And when we think about blue lights, I think many of us may be thinking about how we hear that blue lights may not be that great at night when we're watching our TVs or we have our phones on and we're exposed to all this extra blue light at nights. And the reason why blue lights is not great for us at night when we're trying to fall asleep is that blue light activates our IPRGCs, which will ultimately lead to the suppression of melatonin. So what we want is we want an increase in melatonin. So we want an absence of blue light. And so our IPRGCs are not activated. And so we want to, that leads to an increase in melatonin. and thus better sleep. So when I started learning more about these RGCs, everything over there to the right of the slide about alertness, memory, reaction times, cognitive performance. These are the things that I'm most interested in studying with Parkinson's disease. And sleep affects our cognition. So it really became an exciting adventure to start thinking about research questions with Dr. Gaines. Let me move this over. So the research study that we proposed is with Parkinson's disease. Now, Parkinson's disease is the loss of dopamine in general. We get a loss of dopamine in the brain. And dopamine is also in the retina. So there's lots of dopamine in the eye. There's loss of dopamine in the eye, and this affects iPRGCs. So this affects the function of iPRGCs. And like I said before, Dr. Gaines can measure the function of iPRGCs in his eye clinic. And the way he does this is by measuring the pupillary response. And so the first aim of our research study is determine if iPRGC function is differentially affected based on the severity of Parkinson's disease. So we are recruiting 10 veterans who have stage 1 to 2 Parkinson's disease. And you'll see in the left corner there that the motor deficits aren't that great at stage 1 and 2. So we have 10 veterans with stage 1 to 2 Parkinson's disease. Then we're going to have 10 veterans with stage 3 Parkinson's disease, and then 10 non-Parkinson's veterans. And what we want to do is see how the function of iPRGCs are different across these 3 groups. And our hypothesis is that it's going to be more affected in the Parkinson's disease veterans and most affected in that stage 3 of Parkinson's disease. And here's just a quick demonstration of the persistent pupillary response. So Dr. Gaines will have an individual in his eye clinic. They sit in a dark room, the eye dilates, and then he shines different wavelengths of light, knowing that blue light in particular is going to activate those iPRGCs. And so when the iPRGC is activated, you get a prolonged pupillary constriction. So in the normal, healthy eye, you dilate the eye, you shine a bright light, the pupil constricts, and there's a slow return back to the dilation. People with abnormal responses, such as those with Parkinson's disease, their eye returns to the dilation much quicker. So simple, easy approach to studying iPRGCs in the eye clinic. Moving my slide along. Okay, and so aim 2 of this study is where my interests lie with thinking and memory, with cognition. So I was interested in visual spatial function before I met Dr. Gaines, and I got even more interested once we started working together. But the value of visual spatial function can be seen by our ability to perceive space, to recognize line orientation, depth perception, detection of motion. And all these are affected in Parkinson's disease. And so with walking by a curb, you may trip over a curb. Walking through a hallway, some Parkinson's patients may tend to freeze because the line orientation, and it confuses the brain. So there's this freezing that is associated with that kind of depth perception and lines. So there's value in understanding how may the dysfunction of iPRGCs relate to visual spatial and visual perception processing with Parkinson's disease. And we actually, our group submitted an information educational page to the Archives of Physical Medicine and Rehabilitation that talks about this. So this is actually a second publication that our group is looking to publish. So finally, the implications. Modern pupillometry is fast objective, non-invasive, and a low-cost technique. We can have this throughout the nation in all the VA hospitals. And so this is a vision. We're thinking about reaching out to more of the VAs. Can we get more, get a multi-site study going on? But the questions that we're interested to begin with, how early can we detect IPRGC changes in our veterans with Parkinson's disease? How is the functional IPRGCs related to sleep, to mood, cognition, perception, pain? And not only in Parkinson's disease that we know loss of dopamine is affecting IPRGCs, but throughout the aging population. And then ultimately for rehabilitation purposes, are there light-based therapies that can compensate IPRGC related dysfunctions? And last year, led by Dr. Gaines, our group was awarded a Heinz Innovation Program Award. Dr. Gaines is working with individuals at UIC to create these spectacle goggles that actually has a video recorder in the glasses and that can shine the different wavelengths of light, and we can measure IPRGC function in real time. So with that, teamwork makes the dream work. We have a great team of VA researchers here, and we are working on ideas for a Michael J. Fox Foundation grant. We actually did submit one that did not get funded, but we are writing grants. I have ideas for VA Spire, VA Merit, DoD grants, and NIH funding. So thank you for your time.